Hey there, future architects. Welcome back to the channel and to our deep dive into system design. Now, let me tell you what system design really is beyond textbook definitions. System design is the art and science of planning how large-scale applications are structured, how their components interact, and how data flows through them. This isn't just something senior engineers do at big tech. It's how technology leaders across the industry ensure their systems can handle massive scale, recover from failures, and adapt to changing requirements. System design goes way beyond just writing good code. Think of it like city planning for software. Your APIs are the streets connecting everything, your services are the buildings fulfilling different functions, and your data is the traffic flowing through the system. Whether you're building back-end services, cloud applications, microservices architectures, or data-intensive platforms, you need to focus on how data moves around, how components talk to each other, how to keep everything reliable, how to scale efficiently, and how to manage costs. Master these fundamentals, and you'll be speaking the language of tech leaders everywhere. Listen closely. This might be the most important career advice I'll give you. At companies like Google, Netflix, and Meta, they're not just hiring you for your coding skills. They want to know how you think at scale. Here's a reality check. System design accounts for up to 80% of senior engineering interviews at top tech companies. That's right, it's not just about algorithms and data structures anymore. The consequences of poor system design are serious. Downtime that costs millions, data loss that destroys trust, terrible user experiences, and platforms that collapse under their own success. It's the difference between an app that works for your friends versus one that works for the entire planet. And don't think this is just FAANG territory. System design is critical in startups that need to scale quickly, fintech applications handling sensitive transactions, educational platforms serving millions of students, gaming systems supporting concurrent players, and modern AI infrastructure. Mastering system design helps you collaborate effectively with developers, SREs, product managers, and CTOs. It's the common language of building technology at scale. Let me show you how the apps and services you use every day are masterpieces of system design. Take Netflix. They're serving more than 230 million global users with uninterrupted streaming thanks to their horizontal scaling approach, content delivery networks, and custom load balancing systems. WhatsApp is another fascinating example. They served 400 million users with just 50 engineers by leveraging event-driven architecture. That's the power of smart system design. When you click Buy Now on Amazon, you're triggering a symphony of over 100 microservices communicating in real time. That seamless experience is pure system design. Ever wondered how Zoom and Google Meet maintain video quality even when your internet connection gets shaky? Or how YouTube Live handles millions of concurrent viewers? These aren't coding problems, they're system design challenges. Every viral app you've used worked under enormous pressure because someone thought carefully about its design before writing a single line of code. That's the difference great system design makes in the real world. Let's be clear about something important. Writing code and designing systems are two very different skills. Writing code is about solving a specific problem with logic and features. System design is about solving that same problem for scale, for millions of users, and for rock-solid reliability. When you're coding, you're focused on algorithms and functions. But system design forces you to think about latency, uptime, scalability, and cost. These are the factors that determine whether your application succeeds in the real world. System design is where you make the big architectural decisions. SQL or NoSQL, message queues or event streams, monolith or microservices. These choices have long-lasting consequences. Here's the truth. You write code once, but your design decisions live for years and affect entire engineering teams. Poor system design leads to the nightmare scenarios every engineer fears: downtime during peak traffic, costly outages, frustrated users, and skyrocketing server costs. The highest paid engineers aren't just great coders, they're great system designers. That's the skill that technology leaders actually pay top dollar for, and it's what I'm going to help you master in this series. Now, let's break down what we're actually talking about when we say system. A modern application system has multiple layers working together seamlessly. Starting from the outside, we have clients. That's your mobile apps, web interfaces, and desktop applications that users interact with directly. Behind them, we typically have API gateways that serve as the entry points to your system, routing requests, handling authentication, and managing access control. Next comes your application layer, which contains all your business logic, often broken down into microservices that handle specific functions. Then we have databases, whether they're relational like PostgreSQL, NoSQL like MongoDB, or specialized time series databases. To speed things up, we implement caches using technologies like Redis or Memcached, or content delivery networks for static assets. For reliability, we add load balancers to distribute traffic and failover systems to handle outages. And finally, to handle asynchronous communication between services, we use message queues like Kafka or RabbitMQ. Throughout this series, I'm going to equip you with practical skills that will transform how you build and think about software. You'll learn how companies like Netflix handle massive traffic spikes by implementing intelligent load balancing strategies that distribute requests efficiently across servers. I'll show you how to dramatically speed up applications using strategic caching at different layers of your system, from database query results to API responses to static assets. We'll explore how to break down monolithic applications into sharded databases and microservices that can scale independently as your user base grows. You'll discover how to properly secure and manage APIs using gateways that handle authentication, rate limiting, and access control, protecting your system from abuse while ensuring legitimate users have a smooth experience. One of the most valuable skills you'll develop is the ability to draw and explain real-world systems. We'll reverse engineer architectures behind platforms like Instagram, YouTube, and Uber so you understand how they actually work. And finally, you'll learn how to defend your design decisions in technical interviews or architecture reviews, a critical skill for landing those high-paying senior roles. By the end of this series, you'll be thinking about software the way architects do, not just as individual lines of code, but as interconnected systems designed for scale. Here's a real challenge for you to test your system design thinking. Imagine you're building an exam portal that needs to handle 1 million students taking tests simultaneously. What would be your biggest system concern? Would it be database performance under heavy write loads? Authentication systems to prevent fraud? Real-time monitoring to detect cheating? Or maybe handling the traffic spike when everyone submits their answers in the final minutes? Drop your thoughts in the comments below. I'm looking for insightful answers that show system thinking. I'll feature the smartest responses in future episodes and maybe even build on your ideas. In our next episode, we're going to get practical and learn how to scale like Netflix. All this and more coming up in episode 2. Scale like Netflix. Intro to Scalability and Load. Make sure you're subscribed so you don't miss it. If you found value in today's breakdown, hit that subscribe button right now. This series will teach you what no college course covers: how to build systems that can scale to billions of users without breaking a sweat. These are the exact skills that top companies pay six-figure salaries for, and I'm sharing everything I've learned from years in the trenches at scale. Don't miss the next episode.